Okay, so hang with me. It's about to get wild. Now, you're going to have to. Well, not that wild. We're not going that direction. We're going the other direction. Okay, so we're going to need to. It's going to get fuzzy on the first. And generally, I think I'm going to use this for my first page. This mathematics. Now, this gets pretty heavy. We can get in here and crack it open, I think. Capacitor. We'll get why here in a minute.
Hello class, Dr. Anderson here. Let's talk about the leaning ladder problem.
He's going to jump
So
through a
in this
couple of
problem,
boxes
we have the
real
following
quick.
setup. We have a floor and a wall, and we have a ladder.
This is
that's
NP
leaning
completeness
against
right
the wall.
here about this
Now,
little
there's
diode and what
friction
it's made out of on
on
the
the floor
hydrogen periodic table. Now this,
with coefficient of friction
plus some of those
e
other
sub s.
videos on my
The
Facebook
wall
timeline.
is friction.
Well, it's not going to let me. But we'll get into that here in a minute. I'll show you what I can do clipping in, coming back on it. Come on. Oh, you got to be kidding me. Come on. No. Alright, well anyway. That gets pretty comprehensive in terms of what these NP problems are about, doing some stuff. And hopefully I did put it up in here because I've been watching a lot of his stuff. Let's see which one it is. Yeah, some of this stuff in here about electron potential, what you're getting into to some of this field mechanics and what you're doing with it is pretty comprehensive stuff. I think I did the first one too while I'm working. Why this to... I wanted to skip steps, Ben Eater and electrical people. I really did. I wanted to let you catch me in the bunny trap, but we got to build to the 555 logic before I can take some of Ben Eater's stuff of the earlier. Like, without this, then you're going to skip a step inside of here that's going to be pretty important on some of this Xeno, or the Z diode here, a light emitting diode, which is this guy right here, photodiode, so the light receiving diode, and you can make these things flash at each other on a very high, small scale, very later. We're not going to be needing any of that for all intents and purposes. We have met the LED, we have met a resistor, which is kind of a diode in a different way, like the wire and the battery, and doing it this way comparatively to the breadboard. Yes, is it the right answer? But we're going to run the power source version through a breadboard. You got to have the breadboard first. Yes, this diagram, I'm sure you can hook up the wires and get the junction inside of here, but we are going to be using transistors, and I'm not sure whether that is the positive kind where we're doing it this way or the negative kind, because Ben Eater didn't go that route about it, and which is super confusing. But when you're dealing with some of this math inside of here, he'll get into... Wow, I wish I could just take it to the clip and get right on here on the line and be like, so that's the math? And I'm going to be like, yeah, that's the math. And you can't really much get around this logic gate while building to it, because there's a couple of different real base types that are super important, and you don't want to be missing them. In terms of what this little... Let's see if I can get it inside here. This little logic gate inside of here, we have to build to the and, we have to build to the or, we have to build to the exclusively and, exclusively or, and so into this, I'm pretty sure that is what is happening, right? I'm pretty sure in the pan out there, that's what's going on. With the proper ratio, you'll get into how to use it, why to use it, what to do with it, the volume of the volume, the whole thing from the back to the roots, figuring out why the thing needs to do this to build into the binary calculator that you're going to need. A little different inside of the setup. Again, here, we want to make sure that we're taking the logic gate principle as well, building it into there. So is that the M4 and 5 routes? And now that I've hopefully built the mathematics in row 1, I got a diode and a capacitor, where I'm really getting into what the diodes are, because we already got some of the LED stuff on the electric bunny. The other one there, where'd we go? Yeah, here we go. Electric bunny farm. doing the electron buzz. And some basic binary stuff. There's some real bitty, itty bitty, tiny logic gates that Ben Eater's going to cover a little bit better about why it's doing that. But here's again that charge to the base and having two different fields that teach that by not going breadboard. Do the breadboard version and then show me where the diode slips into that, because then we're going to make some alterations to why it can do certain things based on the mathematics when you actually get into the electron potential, what's going on with F and B fields, the Q-ons at Q with the partial derivative of Q, little q, N over R2 over as a larger derivative R2 being the Q-ons inside of this, the K. And K can be V and I, and you got infrared, the video control technician, and the video interrogator, right? So that'll get you the pyramid. And so with me, again, I'm working this route, and I want to, again, we're going to be incorporating, let's just slide back up, make sure I'm trying to get the principle of what I'm getting in here. We're going to need these in a set, this in its first set, and you actually watch the mechanics. Why this ladder and climbing the ladder? Because we can make that a logic gate, right? We can make that a Z diode on the capacitance of things inside of the NP problem to the wave function, and it works like fundamental analysis. And that's what these wires are doing. We already got the bunny farm, right? We already got the wire, the bunny, some of that field stuff. It's working through. We need to make the short inside of here to do it, but we don't have the proper logic and what the geometry would be in the real world. So it's going to get a little squishy about putting these three in one brick, right? That being the first one, all a part of condensing into this, and I'm not exactly sure what I want to do in here. Here I'm not too bad with. I think we can get 3 bricks in there, no problem, as far as one row. But how do I want to break down the quadrants on this thing so I get the right conceptual model of a standard diode from an LED, very comprehensive, kind of like receiving diode, a photo diode there, or this basic system where if I flip the current around, right, we want it going the other way, it'll still bridge a circuit the way I want it to, and not make for a problem in the same and or way that is the magic in electrical engineering that messes up all the kids and does things with it, but mechanically it makes perfect sense. And also capacitors? Okay, so there's the first one, there's the second one. We use capacitors as the third because it would be diodes to capacitors, and these are all diodes. So in its own little third little break to a capacitor on the third row. Then we could get into the timing delay on the fourth brick, which gets us into the power source, cutting the head off of the USB cord and getting 2 power sources on the LED with 2 buttons going at it, and the variables on that transistor, which we're going to need for building logic gates, right? I'm pretty sure that's where I can slip back into Ben Eater stuff. So we'll double down on a video here in a minute and we'll try that out.